Hello. What you are seeing is the graphical user interface of expeyes. So the main component of that is an oscilloscope. And what is an oscilloscope? It's a device that can plot voltage as a function of time. So here you can see the graph. We have connected a sine wave to the channel A1. The oscilloscope has 4 inputs, A1, A2, A3 and the microphone input. So here you can change this time base, like now it is 0 to 2 millisecond. You can just adjust it to say 5 millisecond, or whichever way you can make it 1 millisecond. That is a minimum. So leave it at the 2 millisecond. So this is one channel, and this input maximum input range, input range you can change from here. So if you can make it up to 16, but normally if you have signal, suppose if it is something more than 10 or so, you should select this range. But since our signal is only 3 volt, we are changing so that the range selection should be more than the signal amplitude. So let us look at the other signals, A2. So A2, there is nothing now, so we can just give something there. So there is a square wave on A2, right? And say A2, if I keep it 4 volt, again it will clip. So A2, since it is a 5 volt signal, I should keep it at 8 volts. And another channel is A3. So what I have done is I just connected a PN junction from A1 to A3. So you see the half wave rectified waveform on A3, and microphone is not connected, so there is no signal here. So now let us remove them one by one. And there are certain things which you should know about this. One other control like time base you have seen. Other one is the trigger source. See, the trigger is something which decides the starting point of the trace, and if it is not triggered proper, you will not get a stable signal. Suppose if I say trigger from A2, see there is no signal on A2, so it cannot trigger. You can A1. So now if you change the trigger level, you can see the starting point of the waveform is changing, right? So you can start from the negative levels, or in the middle at the 0, or at the positive levels, or you can trigger from a different channel. Like if I choose A2, and I can trigger from A2, so I should go slightly positive because it is starting at 0. Okay, so this is how the trigger mechanism works. And now you have a cursor here. If you enable that, you can move the cursor, and at the cursor point it will show the voltage of all the channels. So if you want measurement, so you can use the cursor. Then there are pull down menus. The first pull down menu, this is a device reconnect. See, by chance, suppose your device cable got disconnected or something, you should put it back and then say device reconnect. You should press here. And this is to change the background. And this background is useful if we are using an LCD projector. Otherwise, this is okay. And another one here is to choose the language. So by default, it is coming in English. So you can change the GUI into, now it is in French, and other languages implemented are Spanish is there, and so now it is in Malayalam. Then you can take screenshots also. Okay, that is the first menu. And then the second menu is, okay, let's go back to English. So the second menu is school experiments. These are very simple activities, that is mainly to get familiar with expeyes and also to have some familiarity with the basic concepts of physics. And then there is a third menu, electronics, and first item is oscilloscope. Actually, you are in the oscilloscope now, and oscilloscope is, when you start the program, it comes into this oscilloscope. Then you can choose other several experiments. Actually, you give a different name, but they are done using oscilloscope. But there are other experiments where the GUI will change totally. And then there are electrical menu and the sound menu, mechanics menu, other experiments, say temperature measurement, then I2C modules, and coding in Python. You can write your own program and see the communicate to hardware and see the output. Okay, so then on this side you will find some tick marks, A1. If I tick that, you can see this just jumping around. Actually what is happening is it is measuring the instantaneous voltage of on A1. So to make anything, see anything meaningful, I have to connect it to a DC source. So what I do is I connect that to the programmable voltage source. It is at 0, but I can come here and set it to something different. See, now I set this to 2 volt, I can see here 2 volt, and that 2 volt will vanish if I remove the cable. See, so it's a real voltage there. Similarly, you can connect here to, so these check boxes are to use A1, A2, A3 as DC voltmeters. Then here, if you connect a capacitance to in 1, you click here to measure the capacitance. Similarly, the frequency and duty cycle of a square wave and in 2, you connect this and click here to measure it. And this checkbox is to make OD1 high and low. This is to enable constant current source. Then here the waveform generator, you can change from sine to triangle or square, and you can change the amplitude from 1 volt or 3 volt or 80 millivolts. These sliders are changing the waveform generator frequency, and that goes from say 1 kilohertz, so 5 hertz to 5 kilohertz. Same with this. Voltage of PV1 you can go from -5 to 5 volt. See, PV1 is connected. When you move this, you can see the trace is also moving because it is connected to A1. So that is roughly the very basic features of the GUI, and then we will suppose let's just take a simple example, one experiment. We take it as, take that to say half wave rectifier, or before going, I mean I have to just explain one more thing, that is the pop-up help window. So here the video is actually only showing this window, so when you do this, it is going to come up outside this area. So I have to drag this in to show it to you what is the help. Okay, this is something which has popped up. Okay, so here in the oscilloscope, so when you ask for help, the complete information about all these things is available. Now if you change and go to say half wave rectifier, nothing changes here because half wave rectifier is done using oscilloscope only, but your help window gives you all the information, what is the kind of connection you have to do and what is the procedure you have to follow and what will be the expected output, and everything will be given. So there is an extensive online help. That is true for, suppose say if you come here, do something like say capacitance in parallel. So this will show you how to make the connections and to make the measurements. So this is it probably gives you some rough idea about the GUI.